In this problem, we have two cars, car A and car B. Car A is traveling at 30 miles per hour with an acceleration of 12 feet per second squared to the right. Car B is traveling at 60 miles an hour with an acceleration of 10 feet per second squared to the right. The distance between the cars is 300 feet. We want to find the velocity of car B relative to car A and the time it takes for B to catch A. First, let's start with the velocity of B from the perspective of A. Well, the velocity of B from a relative motion equation is equal to the velocity of A plus the velocity of B from the perspective of A. Rewriting this, we get that the velocity of B from the perspective of A is equal to the velocity of B minus the velocity of A, which in this case is 60 miles per hour minus 30 miles per hour, which is equal to 30 miles per hour. But we would prefer to have this in feet per second. So 30 miles per 1 hour, there's 5,280 feet per mile. 1 hour has 3,600 seconds. Therefore, we should get 44 feet per second. Now, there's a couple of ways that we can approach the time for B to catch A. We're going to start by figuring out what the acceleration is of B from the perspective of A, which would be acceleration of B minus acceleration of A, which would be 10 feet per second squared minus 12 feet per second squared, which is equal to minus 2 feet per second squared. We have a constant acceleration, so using our relative motion values for acceleration and velocity, we can calculate how long it's going to take to go that 300 feet. This is like saying that car A is not moving and that car B is going 44 feet per second, but slowing down at a rate of 2 feet per second squared. And we want to find out how long it's going to catch them. So, our final position is equal to our initial position plus initial velocity times the time plus 1/2 at squared. This is our constant acceleration equation that we're going to use. Final position is 300. Initial position is 0. Initial velocity is 44 times t. And since we're at negative 2 feet per second squared, if we put that in for A, the 2's will cancel, so we're at negative t squared, or negative t squared plus 44t minus 300 equals 0. Solving this polynomial, we get two answers. T is equal to 8.435 seconds, and that t is equal to 35.56 seconds. So which one is it? Well, if you can imagine what's happening here, car A is going slower than car B, so there's going to come a point where car B speeds up and catches car A, and then it'll pass car A. But car B is slowing down relative to car A, so eventually car A is going to catch back up to car B. This value is when car A catches back up to car B. So the answer that we want is the first one. This is the first time that the cars will be at the same position, or when car B catches car A. There's another way that we could have done this using our constant acceleration equations. We could have said that car B is at a position 0 and that car A is at a position of 300 initially, but they're going to meet at the same place. So if we said for car B, SF is equal to S naught, which is 0, plus V naught, which is 60 miles an hour. 60 miles per hour is 88 feet per second. So if we said 88 t plus its acceleration plus 10 over 2, 1/2 a t squared. That's what we would have for car B. For car A, we have its initial velocity times the time plus 1/2 a t squared. But I've forgotten something here. We also have an initial position. Its initial position is 300. We know that when they meet, both of these final positions should be the same. So 88t plus 5t squared is equal to 44t plus 6t squared plus 300. Collecting like terms and bringing them all over to the same side, if I bring over this 6t squared over to the left side of the equation, we have a minus t squared. Bring the 44t over to the left side of the equation, we have a 44t because we subtract 44 from 48. And then we move the 300 over, minus 300 equals 0. This equation gives us the same thing as this equation. So relative motion gives us a different way to approach the same problem, but we end up with the same result.